Pre-calculus, 5.3, day 4. We're going to be solving functions that involve multiple angles. So far you've seen things like cosine of theta, tangent theta, etc. But now you're going to see things like cosine 4 theta, tangent theta halves. And so when this angle is not just theta, those are solving trig functions of multiple angles. And just remember, cosine 4 theta, is not 4 cosine theta. You can't move this 4 in and out of the argument. That does not happen. So we have other methods for solving these. So the first thing to do is isolate this trig function. Again, the 2x you got to just leave alone right now. So the 2x stays there, and just add the root 3 over 2 to the other side. And now, when it's sine, cosine, cosecant, secant, you're going to find all angles from 0 to 2 pi. And in this case, that satisfies where just cosine of theta is root 3 over 2. So we're going to start there. So where within one full rotation, one full period of cosine, is it root 3 over 2? And so I'm thinking, okay, that's x. X has to be positive, and root 3 over 2 is going to be right here. And then cosine's also positive in quadrant 4 because x is a positive root 3 over 2, and it's down 1/2. And those two angles, so this is when theta is pi 6 or 11 pi 6. So you need to find those to begin with. Now, since it is not theta, but theta is 2x, we need to say, well, 2x has to be pi 6. And then there was no restriction on the domain. This is how we start, by finding all places where cosine's root 3 over 2 from 0 to 2 pi. But overall, it didn't restrict the domain, so we have to have an infinite number of solutions. So we add on to this plus 2n pi, where n is an integer. And we're going to do the same thing with the second angle, 11 pi 6. We're going to say 2x is equal to 11 pi 6 plus multiples of the period of cosine, which is 2n pi. Now we need to solve for x, so we are going to multiply both sides by 1/2. And you need to make sure you distribute that on the right-hand side. So we're multiplying both sides by 1/2, which gives us an x on the left. And we'll do that to both equations. And then distribute that 1/2. And we have a pi 12ths. And 2n pi times 1/2 is just n pi. And then we have x is 11 pi 12ths plus n pi when you distribute. And then in each problem, you should be stating where n is an element of the integers. And those are your solutions. Let's try it again. But as we move on, notice this note, sine, cosine, cosecant, secant, always find all angles 0 to pi and add 2n pi, and then multiply or divide by the numbers so you can solve for x. That's because their periods are 2 pi. And so every time you go a full rotation around, you will be at a coterminal angle and you will have the same value. However, when you have tangent and cotangent, you only need to find angles 0 to pi because their period is pi, and then add n pi. So we'll see this in this next example. So you need to isolate the tangent of that multiple angle. Again, you can't take that 3 out in front or do anything with it. You just leave it 3x right now. So as I isolate that tangent of 3x, I get a negative root 3. And then I need to find all theta 0 to pi, not including pi, where tangent of theta is negative root 3. So I'm just thinking, I'm not going to be quadrant 1 because tangent's positive there, and I happen to know it's the 2 pi thirds because that's negative 1/2 and up root 3 over 2. And tangent is y over x, so that root 3 over 2 over that negative 1/2 is going to make that negative root 3. So it is, theta is 2 pi thirds. That's the angle where tangent is negative root 3. And so, but it's not theta, theta is 3x. So 3x has to be 2 pi thirds. But because it is tangent and its period is pi, we only add n pi to this. And that's it. Then multiply both sides by 1/3 to get x. On the right, make sure that you distribute that 1/3, and you get a 2 pi ninths plus n pi thirds, where n is an element of the integers. And that's your answer. Example 3. We have cotangent of x halves. So you need to isolate cotangent of x halves. So we're going to get cotangent of x halves equals 1. Since it's cotangent and its period is pi, we're going to find all theta 0 to pi only, where cotangent of theta is 1. So I have to just think in quadrants 1 and 2. Well, quadrant 2, cotangent's negative, so it's got to be quadrant 1. And oh yeah, tangent and cotangent are 1 at that 45 degree or pi fourths, because that's where x and y are the same, and cotangent is x over y, which is going to be 1. So it happens when theta is pi fourths. But then this angle is not just theta, it is x over 2. So x over 2 has to be pi fourths. But the period of cotangent is pi, so we're just going to add n pi. But now to solve for x, you need to multiply both sides by 2. And you get x is this 2 times this quantity. Distribute that 2. 2 times pi 4 simplifies to pi halves. And then plus 2n pi, and that is when n is an element of the integers. So I want you to pause the video and try and do example 4. Let's see how you did. Did you find all angles 0 to 2 pi? Because cosecant goes back to having a period of 2 pi. Let's see. So we have cosecant of 4x is 2. So I need to find all theta. And this is from 0 to 2 pi, where cosecant of theta is 2. So I'm thinking, well, if cosecant theta is 2, since 1 over sine theta is cosecant, that means sine, it's where sine theta is 1/2. It's easier for me to think about it that way. And sine is 1/2 at pi 6 and at 5 pi 6. It's root 3 over 2 up 1/2, or negative root 3 over 2 up 1/2 on the unit circle. So that's where your y value is 1/2. So, but it wasn't theta, it was 4x. So we need 4x to be, well, I didn't write what those were. So they are pi 6 and 5 pi 6 over there. So 4x has to be pi 6, but it needs to be plus 2n pi because it's multiples of the period of cosecant, and the period of cosecant is 2 pi. Or 4x is 5 pi 6 plus 2n pi. And then multiply by 1/4. To solve for x. Make sure you distribute that 1/4. And we have pi over 24 plus 2n pi over 4 is n pi over 2. N pi over 2. And we have 5 pi 24ths plus, again, n pi over 2. That'll reduce. And n is an element, oops, of the integers. How'd you do? There you go.